charge of neutron, what is the relative mass and absolute mass of electron, proton, and neutron. Okay, so here electron, here proton and neutron. So these are the fundamental particles in atom. So the first point is nature. So nature of electron is negatively charged. Nature of electron is negatively charged. Nature of electron is negatively charged. Here the nature of proton is positively charged. Positively charged. Nature of proton is positively charged. So the nature of neutron is electrically neutral. So it is there is no charge. So here it is the nature of neutron is neutral. The second one is absolute mass. Absolute mass. So absolute mass of electron is equal to absolute charge. So then we will move to, after we will move to the mass. Absolute charge is equal to minus 1.602 into 10 to the power of minus 19 coulombs. Here 1.6 plus 1.602 into 10 to the power of minus 19 coulomb. Here it is 0. So there is no charge, neutron. So third one is relative. So we can express in terms of electrostatic units also, that is minus 4.802 into 10 to the power of minus 10 electrostatic units. So this is plus 4.802 into 10 to the power of minus 10 electrostatic units. So here then relative charge. So absolute charge, relative charge. So relative charge of electron is minus 1, proton is plus 1, the relative charge of neutron is 0. The fourth one is absolute mass. Absolute mass. So the mass of an electron is equal to 9.1 into 10 to the power of minus 31 kilogram. Here plus 1.672 into 10 to the power of minus 27 grams, or 1.672 into 10 to the power of minus 24 grams. Here, so only slight changes here. 1.675 into 10 to the power of minus 27 grams, or so 1.675 into 10 to the power of minus 24 grams. So that is the absolute mass. Okay. So the next one is relative mass. Relative mass. So relative mass of an electron is equal to 0.00565 atomic mass units. 0.00565 atomic mass unit. Here, so this is 1.007672 atomic mass units. Here, so 1.008685 atomic mass units. Okay. So here, the last one is 1 mole of mass of 1 mole. Mass of 1 mole. Mass of 1 mole. Mass of 1 mole, that is equal to 0.0056 gram. Here 1.007672 grams. Here 1.008685 grams. So these are the fundamental the values of electron, proton, neutrons which are present in the atom. Okay, so these values are very important. Okay, so these values we can use in numerical problems also. Okay, clear, student? Right. Thank you.
Chemistry.
So after the discovery of electron, proton, and neutron, so J.J. Thomson, he proposed his atomic model in 1898. So he proposed atomic model in 1898. So according to the J.J. Thomson, we know very well already electron was discovered by J.J. Thomson. So according to the J.J. Thomson atomic model, so generally the electrons are the negatively charged particles, we can call it as electrons. So these negatively charged particles are present in the atom. So the countered these negatively charged particles, there must be a positively charged particle should be present in the atom. So he imagined, so here if the negatively charged particles are present in the atom, so these counter of these negatively charged particles, there must be a positively charged particles will be present in the atom. So based on this, he suggested that so atom is a solid sphere. According to the J.J. Thomson, atom is a solid sphere. So according to the J.J. Thomson, atom is a solid sphere. Atom is a solid sphere. Clear? So here what he said that, so the negative, the positive charge, this positively charged is distributed, so over the positively charged, the positive charge is uniformly distributed in the atom. So means here the positive charge density is distributed entire an atom. So here this is the positive charge is distributed entire the atom. And also he believed that the electrons, means the negatively charged particles, are embedded in this positive charge density here. So he believed that, so these electrons are randomly, so the electrons are randomly so distributed, randomly embedded in this positively charged sphere. So here, so we can see that model is look like the watermelon model. So here, because so this is the red flesh of a fruit, and the black seeds we can imagine that is electron. So that's why the J.J. Thomson atomic model, so we can call it as watermelon also. So and also here this is the plum pudding model. So here generally the plum pudding is the famous the Britain dessert. So means here the model of an atom is look like the plum pudding model. So that's why the name of these J.J. Thomson atomic model we can call it also plum pudding model of an atom. So clear, student? Right. So here once again, according to the J.J. Thomson, atom is a solid sphere, and the positively charged is distributed uniformly entire the atom. Uniformly entire the atom means the positive charge density in the atom. And the next point is the electrons are, he believed that the electrons are embedded in the positive charge density. Embedded in the positive charge density of an atom. Positive charge density of an atom. Okay, clear, student? So this is J.J. Thomson atomic model of an atom. But here J.J. Thomson fails to explain the why atoms are stable. So J.J. Thomson atomic model could not explain why atoms are stable. So why the atoms are stable, right? So a series of experiments was done these past years, but many of the scientists said that the J.J. Thomson atomic model is not accurate. So J.J. Thomson atomic model is not accurate. So because here, so these negatively charged particles, when these negatively charged particles
are creased in a small volume, so these electrons may be repulsed to each other. So it may be happen. So that's why the atomic model is not an accurate. So the further experiments was comes out, that is Rutherford gold foil experiment. Okay.